In this video, I will introduce some new packages in R. I will also talk about how to create a function, and we will talk about some new dplyr functions and some graphing. We will go over reporting results in a dashboard. So the two packages we're going to introduce here are ggplot2 and plotly. We'll come to those as we go forward in the code. We're going to use a new data set. This data set uses a large set of companies, and we're going to calculate ROA with that data. I run this, I create a new object called temp, and I use the readr function, read CSV, and this CSV file is available to you. So if I open this, we can look and see we've got the company name, we have an industry code, the standard industrial code. How these codes work is a number. How these codes work is the first number gives the broad category of the industry, and additional numbers make the industry more detailed. So these two, 3564, 3670, these are in the same broad industry, so the 3 industry, but this one is in 35 and this one is in 36. So they're different as the numbers progress from left to right. GV key is a company identifier. F year is fiscal year. So you'll see fiscal years begin in 2015 and they continue on from there. There are a lot of companies, so you can see as 2015 stays in there a while, but we have all the way to 2020. REVT is total revenues, AT is total assets, LT is total liabilities, and NI is net income. You'll also notice that since we have different fiscal years, we have multiple years from the same companies, and we have multiple companies. We'll come back to the data and using it in just a minute, but let me talk about creating some functions in R, and I use these functions to help clean up the data. This is necessary when we're working with this type of data because, as you will see, there end up being some very extreme observations. Normally because we divide by some number when we're creating a ratio, and some of those numbers can be really small. It can also occur because we have companies of very different sizes, some very, very large companies and some very small companies. So how you create a function is you do an object just like we have done before. You name an object. Here I'm calling this one miss. That will be the name of the function that we use later. Function tells it that you're creating a function, and then in the parentheses you input anything that will be used for that function. So here I'm going to use a data set that I'm going to input into the function, and I'm calling that DTA. So the function is within these curly brackets. What I'm going to do is work with the input, which is DTA, or a data set I input. I'm not concerned that you understand the details of this function. What I need you to understand is that it removes missing values, and we'll see that later. At the end of the function, you have to tell it what the output is, and so here the output is a data set, DTA again. So I'm inputting something called DTA. Here I just happen to output something called DTA as well, but the last thing that has to come from a function is the output that you have here, and you're not doing anything to it, you just output it. The same thing with this second function, OUTL, outlier is what I'm telling it is. And this one takes a column or a part of an object and takes extremes and makes them less extreme. So this is called Windsorizing. And so in the Windsorizing, what we're doing is taking something that is greater than the 99th percentile and setting it equal to the 99th percentile. Something that is less than the first percentile, we set it equal to the first percentile. So I use things like this to help make cleaning up the data simple. So first, let's look at the data so we can understand it a little bit. So we had something called view before. We have another function called head. That just outputs the first little bit of the data. So I'm going to run that, and you can see down here that it gives me the beginning of the data set, and it's just like what we looked at when we opened the data set. We can do a summary of the data. And you can see we've got fiscal years from 2015 to 2020. The minimum of revenue and assets is 10 million. These are in millions of dollars. I just required it to be at least 10 million. Liabilities, we have some that have 0 liabilities. Net income goes from a very big negative to a very big positive, and the largest revenues are quite large, and the largest assets and liabilities are quite large as well. So this gives us very unique distributions. They're not normal distributions, and so it creates some challenges when we work with financial data, particularly when we look at a big cross-section of companies that are not very similar in size. So we're going to create a new variable. This is ROA, return on assets. So that's net income from a year. So let's say net income from 2020 divided by assets from the prior year. So this would be 2019. So for each year, we're going to take net income for a company, divide by assets from the prior year. Well, how we do that in the data, if we look at what the data looks like again, notice right now the data is sorted by year and then company within that year. So if I wanted to get the data for the same company from a prior year, we need to arrange the data a little bit differently. So we're going to sort the data by company identifier and year. So when we run this, we can open up the data and see now it's sorted by company, or really by the company ID, and by each year. So then what we want to do is each year, so let's say 2019 here, we want to take net income and divide by total assets from the prior year. So this function is called a lag function, which what that does is say we're working in each row, so it works in one row at a time. So let's say we start here and we have net income from 2020. We want to divide by the prior year. So while we're working in this row, we need to tell it to look to a different row. So here we have net income from this year. We need to tell it to look in the asset column, but go back a year. And that's what the lag does. Lag says move up a row. Lead says move down a row. So in this code here, I'm saying take net income, divide by lagged assets, and I'm lagging by one row. If I did 2, then I would go up 2 rows, or 3, up 3 rows, etc. So here I take net income divided by the prior year's assets. Well, then if I'm working in this row, it will do something similar. Take net income, divide by assets in the prior row, and each row it will go through the same calculation. Notice when we're here, we take net income, there's no assets from a prior year, so it will set this to missing because it won't work in that year. Here let's go to this next company, American Airlines Group. If we want to take net income and divide by the prior year assets, well, notice if I move up a row, it doesn't know that that's a separate company. So we could get something wrong when we divide this net income by this assets. So we have to tell it to do something differently here as well. So let me show you how this works in dplyr. So I'm going to create a new object. I'm just calling it temp2 from the temp data set we already have. And I'm going to arrange it by company and year. That's what we've already done. And for fun, I'm going to show you what if we had multiple observations per year. So I'm going to only keep ones that are not duplicates. So I'm going to take company and year and keep all of the other columns as well. That will remove any that have duplicate companies and years. Then we're going to group by company identifier. The reason we do that is because we want it to do any lead or lag functions separately for each company. So when we're creating this data set, what it's going to do is say, I'm working with this company only. Here's this company identifier. Once I get to a new identifier, I start over again. And what that allows it to do is say, when I'm working to do a lag, so I have this net income, I'm going to do a lag, it will say, this is the beginning for that company. It can't go back into a lag here. So we group by the group that we want to run this by. So mutate, remember, is creating a new column. I'm going to create a new column ROA, which is taking net income divided by the lagged total assets, which is going up one row. We could lead, which would move down a row. So once I run this, and remember every time I do a group by, I ungroup afterwards so that I don't inadvertently use that in the future. So I run this, and if I look at this, I can do this head function to go ahead and look at it. Notice I have ROA, that is a new column, and in the first instance for this company, it's missing because it couldn't take net income and divide by a prior year total assets. So this ROA is just net income from this row divided by total assets from this row, and similarly all the way down. We could also look at what that particular column is. So how we can identify a column is this $ operator. This says take an object, then something within that object. So if we have a data frame, this is the data frame. Then within that is a column. So this will say take data frame temp2, find the column ROA. So just as we did summary before for a whole data set, we can do the same thing for a column. So I'm going to take the summary of the data set temp2 column ROA. So I run this, and this gives me some information about ROA that I've just created. Notice I have a bunch of missing values. Those were created because we don't have lag values for the first instance that a company is in the data set. ROA is return on assets, so think of a return you might get in the stock market or in a bank account. Those are typically percentage terms. So here the median is a 1.6% return, mean is a slightly negative, third quartile 5.8%. Well, we have these really large values, 5.7, which would be 500%, minus 6.9, that would be minus 700%. These occur because we have companies with very small asset values in the prior year. So because of these really large outliers, we may want to make some adjustments to be able to do things with that and not have outliers drive our results. Additionally, we can't use these missing values, so we're going to do some cleanup here. So first, let's remove any missing values. How we're going to do that is use this miss function. So I created this function. I need to input a data frame. My data frame is temp2. I'm going to create a new object, temp3. I run that. Notice over here what happened. We went from temp2, where we had 35,000 observations. We now have 27,000 observations. That's because we removed all the missing values. And you can do this by looking at the number of rows. In row is a function for the number of rows, so it'll show you here, and it'll show you here. We can now take the summary of that data, and notice it looks the same, but now we just don't have this missing values. Well, let's do the next thing, which is removing outliers. And outliers, I created the function to only work on a column rather than the whole data frame. So I'm going to take the temp3, I'm going to group by year, and the reason I want to do that is I want to remove outliers every fiscal year, or we could do that on the entire data set. What we wouldn't want to do is have group by company here. Unless we had lots of observations for the company, we're going to do some weird things to it. So group by fiscal year, mutate creates a new column. I'm just going to overwrite the column. It's going to create a new column, but it's going to name it the same as the old column. So create a new column ROA. That is applying the outlier function to the column ROA, which will make things less extreme, and then I'm going to ungroup. So if I do this and then look at the summary of that data, notice what has happened is our max is now 37 or 38%, our min is minus 85%. So it took things that were at the very extremes and just moved those data points in a little bit. What this allows us to do is use data that doesn't have outliers that are quite as extreme. So once we have this, we're going to use this package ggplot2, and how we do that is use the function ggplot, and the first thing that goes into that is a data frame. So here I'm using temp3, the one we created. AES is the aesthetics of the graph, so this tells it what is going to go into the graph. So here I just need a single variable, so I'm going to have x equals ROA. So I'm going to only use ROA. I'm going to create a histogram. So a histogram shows sort of the distribution of the data. So how we do that is we add a new item to the plot. So here, if we just run this first part, there's no plot. This tells R what needs to go into the plot, but doesn't tell it what to do for the plot. So we tell it what needs to go into the plot, add something to it. That's how we add anything to these graphs. And what we're going to add to it is a histogram. So this is the function for histogram. And to mess around with it and make it look a little nicer, I'm going to color it black and make the fill gray. This is a light gray. So I could stop there, but let me add a couple of other things. So I'm going to add this theme classic, which makes it look a little cleaner in my opinion. You don't need to have this part. And then we're going to add some labels. And in the labels, I'm going to add a title. And then I'm going to add the x-axis label and the y-axis label. So when I run this, what's going to come out is a histogram. So in the plot window, it gives us a histogram. And what you see now is that we have a distribution. Most of the distribution is near zero with a long tail that goes out to the left. So this is sort of like a normal distribution, but it's skewed with a longer tail to the left. So we might use this then to look at the data. If you did this without Windsorizing the extremes, it would look really weird because you have these really big outliers here. Next, let's try something a little bit different, and this is going to show you a dplyr function that we can use as well, and we did some of this last time. But what I would like to do is look at the average ROA every year. That will give an XY plot rather than a histogram. And there are a lot of other things you can look up. So if you wanted to try and see what other options are available, you could look up online and you see here's something that, well, DataCamp, you don't need to look at those. Like here, ggplot2 gives you a cheat sheet that you can use a bunch of different functions with ggplot, gives an overview here of what you can do with this plotting package. Okay, so with dplyr, I'm going to group by every year, and then I'm going to take the average ROA for each year. So in the data, what we can see is we have a single observation for each year, and we have an average ROA for each of those years. So I can create the same sort of idea with the plot. ggplot function, I'm going to save that as an object that I'm calling G. You'll see the reason for that in just a minute. So it's going to save it there before actually outputting a plot. So I have this ggplot function. I'm using the temp4 data that I just created. My x variable is going to be fiscal year. My y variable is going to be ROA. When we summarize, remember it only outputs the column we created and the group by variable. Then I'm going to add a line. So I'm adding something here. Instead of the histogram, I'm adding a line. I'm going to color the line blue, and size can adjust how large the line is. So I want it to be just a little bit larger than it normally is, so I'm putting in a 1. You can adjust that any way you'd like. I'm going to add something else, which are points. This gives us a scatter plot, and I'm going to add those points so that I can see specifically the observations we have. I'm going to color that black and make it a little bit larger. Again, this theme, this just makes it look nicer, I think, and then we're going to change some of the labels. So when I run this, it saves it as an object G. Doesn't show me anything. That's because I've got it over here. So then I can just output it when I'm ready, hit G. Need the plot window to be a little bit bigger. And notice now it gives me an XY plot, the geometric point. These points are the scatter plot points, and the line is this line. Well, with the data we have, it looks like ROA on average for these companies was near 0 in 2016, went up a little bit in 2017, and since then has gone down. We can use this other package, this plotly package, and we can make it a little bit more interactive in the plot. All we need to do is take that same ggplot graph and use the function ggplot2. And it looks the same, right? But when we hover over it, notice it tells us a little bit of information about the points that we're plotting. Of course, there are other plotting functions we could use that are even more interactive, but this gives us a little piece of it that is easy to do here. In addition to outputting individual graphs and tables and things like that, we sometimes might want to put all of the information together, and we're going to use R Markdown to do that. And R Markdown, what it does is create an environment that we can output web pages, PDFs, other types of documents from our R code. The particular R Markdown we're going to use here is flexdashboard, which creates a simple dashboard output from our data. An easy way to get started with this is if we go up to File, create a new file, go to R Markdown, and we can use a Shiny app, which is something else we could talk about. We could create a PDF, an HTML, or a Word document. Here we're going to go from template. If you've installed flexdashboard, then you can click on this flexdashboard. Okay. Now it opens a new file and it sets it up for you, so most of it is already done and ready for you to work with. So you could just start copying and pasting and putting things in here. And similarly, you could do that with other templates that they have available. So let me talk about what the flexdashboard does and how we use an R Markdown file and how we create a dashboard. So the first part here is the YAML, so like the introductory information that is going to tell R Markdown how to read this. And we add a title here. Our output is going to be from flexdashboard, and this is a little bit of information about how to set it up. When you start, you can do defaults here. Of course, if you want to go into more details about how to create a fancy looking dashboard, you could do that as well, but we won't spend time on that here. Then to include our code in a dashboard or in R Markdown in general, we need this part here. So to use our code in your dashboard or in an R Markdown document, we need this here. And in particular, we just need this first part. So we need this with a closing curly brackets. When you first begin, you also need this setup here. This will do things that are created to be used during the dashboard, but are not actually included in your dashboard itself. So setup and then include equals false. There are lots of other options you can use here as well. So when we first start, we need to tell it all of these packages we're going to use, which are the ones we've talked about so far. I'm going to use these same functions we already have. I'm going to do the same data setups we've already done. So this is all just combining everything that was in the earlier code and outputting an ROA that has been cleaned up. Then we also did an average ROA for each year. Well, I'm going to add one more thing here. I want to do an average ROA by industry and year. So let me show you how to do that. So we have this SIC code. One way we can take a piece of that code is using the substring function. So all that does is chop up a piece of the string. So here it says take SIC, start at the first digit of the SIC code or the first character place, and only go to the first character place. If we want to do 2 digits, we could start with 1 and then do 2, or any number here, 1 to 4, because we have 4 spaces in that SIC code. I'm just going to use the first number of that string. So when I run this, I'm going to have an industry code that is just a 1-digit industry code. Then I group by this. We did this before. I'm going to group by the industry, comma, the year. And this will give me an average ROA. Because I do mean, it's going to give me an average ROA for each industry and each year. So we'll see that as we run it, or we can run it right now actually so you can see it. So how this will work, I'm going to run all of this. And then we can see in temp3 what it looks like. I've got an industry, so the first digit was 0, that year, that ROA, similarly for other industries and years. Okay, so then to end the R code chunk, so I've got this here. This is to start that chunk, then this is to end that chunk. Okay, some of the output will go here too as well. Then once I've done the setup, then I need to tell it how to output into the dashboard. There are, again, lots of ways you can do this. This is all close to the default. I just messed around a little bit with the widths. So this tells it create a column with the data width 650. You can do different measures of that as well. So we create the column with a little bit of information about how wide we want the column, and then the dashed line tells it where to begin that column. Then anything that's going to go in that column is going to come after this, and notice we have a second column here with a slightly smaller width and information in that column. So then how we tell it parts of that column to use is the 3 number signs, 3 hashtags, and then the title. So I'm going to create a new part of that column. I'm going to call it mean ROA. I'm going to do another one here, industry ROA. And in the other column, I'm going to create 2 parts of that column as well. So then I can just put information in those parts of the columns. So here I'm going to do the graph just like I did before, this ggplot output G. Here I'm going to graph the new data that I created. And remember, that is mean ROA by year and by industry. Well, one way to do that in the plot is to create groups. And the way we can do that is to tell it the color is going to depend on something that's in the data frame, which here is the industry. So it's going to create a different colored line for each industry here. We could do line type, we could do other things, sizes, things like that, but here we're just going to do it by color. Then once we have this color, the different groups of the color, everything else remains the same in the code. And I'm going to use the Plotly version to output this. Then in this part of the column, I'm just going to type some information in that says what this dashboard is about. And we've done this before. I'm doing the summary of ROA, and I'm just doing that column, so this data frame, this column. But I'm going to round the numbers because there are lots of decimal places. So round, comma, gives the digits. I'm going to do 2 digits. So that's it. It's really quite easy. You want to add another part to the column, you just add 3 hashtags and a title, and then type in more information here. Once we have this set up, then we just hit knit. And that's going to output as a HTML file the dashboard that we have. Of course, we can use different pages. We could talk about that later in your dashboard. The different pages, all that does is instead of using 3 hashtags, you use 1 and create a new page and then start all over again, the same format. So this would be a single page dashboard. So we can see here, since we grouped by industry, we've got different colors for each line of an industry, and because we use the Plotly, I can hover on that and see a little bit about that was the industry 0, the ROA was 3% or 3.7%, and that was from 2018. I can go back here to 2017. Similarly, I can hover over each of these parts of the lines. We've already seen these ROA statistics, and then notice it gives me the information that I input into the dashboard. We have this column that's a little bit wider than this column. We have the title up here, and we can mess around and adjust this dashboard as much as we want. We won't go into all the details about how to do that, but the benefit of the dashboard is that we can summarize a lot of information all in one place.